right. I'm going to kick off the business section of this morning's presentations. My name is Brian Fuchs. I'm with Gore Associates, and I just want to thank the organizers of the Water and Wastewater Management group for inviting me, and I'm both honored and humbled to be here and speak to you today. Next slide. So I'm with Gore Associates. Our company was founded in 1958. We're 10,000 associates strong. We do more than $3 billion in revenue. We're a privately held company, headquartered in the United States with global manufacturing, and we're organized around 3 divisions. Many of you know our most recognizable brand, which is Gore-Tex, which is used as a protective outerwear for sports, as well as first responders, military, fire brigades, and police uniforms. But what you may not know is that Gore Associates, of the $3 billion, $2 billion of that is in medical products division. So the same product that we use for our waterproof breathable membrane outerwear is also used for implantable medical devices. And then finally, we have a performance solutions division, which does electronics and industrial products. So pretty much everyone in this room has a cell phone, and there is a Gore membrane, which acts as the electromagnetic shield, which helps deflect radiation from the cell phone. So it's in pretty much a lot of products that you use on a daily basis. So why am I here? Why is a company like Gore speaking to you today about water and wastewater management? Well, equally as important for having clean water and clean air is also healthy soils. Organics recovery and the beneficial reuse of compost helps sustain the world and part of making a healthy environment. So, organics recovery. Where do we find organics? We are the ones that generate organic waste, and it comes in 3 areas. We can take our organics from wastewater treatment plants, which is eventually converted into a biosolids, and there's different disposal methods where it can end up in the landfill. It can go to incineration for energy production, or we can convert it into a Class A product for composting. The second waste stream that we take a look at is municipal solid waste. And again, either it ends up in the landfill, it can go to incineration for energy production, or we can separately collect it and move it towards a compost product. And finally, for those areas that actually do source separation, either in the food or agricultural industry or at the residential or commercial level, if we can pull the organics out of the waste stream, called source separated organics, we can aerobically treat it, turn it into compost, or we can anaerobically digest it, create energy, and then take the residual and move that into an agricultural product. So composting is fairly simple. I think we all know that we can take the food waste, which we consider our brown material, take our wood waste, our brown material, which is our carbon. We take our green material, which is our food waste, which is our nitrogen. We combine the carbon and nitrogen together. We add a little water, we add some air, and we let the microbes do their work, and the outcome is compost, which is a beautiful, what we call gardener's gold, and go to agricultural use. But there are challenges with composting. Both with the technology and also along with the whole value chain in converting organics into a finished product. The first picture on the upper right-hand side, we call that's a low technology. We do open windrow technology. Then you have a mid-level technology, which could be an aerated process. And finally, the most expensive might be putting it inside a building and using mechanical agitation. There's different challenges. Number one, you just have to figure out how to separately collect it and get it to the processing facility. You have to deal with contamination, plastics, glass. I'm going to repeat this probably several times through my presentation, but odors is always an issue for being a nuisance or a bad neighbor, so you have to control odors in the composting process. Challenges with cost to operate, regulations, and then of course we want to produce a high quality product. Next slide. So today, you can come see me in my booth. I can talk to you further throughout the day, but I bring you experience today about composting organic feedstocks. So either it's source separated organics, or we're talking about green material or food waste organics. We can talk about Class A biosolids, which is your wastewater treatment sludge. And then we have a third application for separating organics from the municipal solid waste stream. I can also bring you experience on alternative feedstocks and anaerobic digestion from the biogas production. So when we talk about animal residuals and manures, we also process those type of feedstocks. We also take the residuals off of anaerobic digestion systems for both low solids and high solids process, or dry or wet fermentation. Next slide. So how does it work? How does the Gore cover work? Well, we take the same membrane that we employ in our fabrics for our apparel divisions, and we apply it to a large-scale cover. The membrane's primary function is to allow for vapor molecule transportation, but does not allow for liquid molecule transportation. And when we combine that with positive aeration, we establish an aerobic process. And the water is key and essential to life. It's also key and essential to keeping the microbes for doing their business and converting these organics into usable, beneficial agricultural soils. At the same time, by capturing the moisture underneath the cover, that gives us our odor and our VOC, or volatile organic compound emission control. So basically, by having an encapsulated process, we can deliver an in-vessel system without the need for buildings or structures. So we've done significant amount of testing. We've been building facilities for almost 20 years now worldwide. The European standard for odor control and reducing greenhouse gases. And in North America, there's a regulation in controlling volatile organic compounds for compliance. We're able to achieve a greater than 90% control compared to uncontrolled systems. And you can see the level of testing that we're doing there in the United States and California, where it's regulated. So I'm going to just show you some pictures of some different reference facilities. So from a large-scale composting perspective, we have facilities that range from 200 to 1 million tons per year. The one on the left is the city of Seattle. It processes 200,000 tons per year from the residential and commercial program for converting their organics to compost. The picture on the right is Los Angeles County sanitation districts in the United States, where they're processing their biosolids. This is the first stage of a 1 million ton per year facility. First stage of 5. The first one's processing 200,000 tons. Next slide. This is a medium-scale composting facility. These process anywhere from 20 to 100,000 tons per year. Again, the objective is to produce a high-quality product, and by regulatory demand, we have to control volatile organic compounds, in which we're achieving in the high 90 percentile for reducing greenhouse gases. The secondary objective being California, it's all about water management and water quality. So the technology allows them to separate leachate from stormwater, which gives them stormwater control, and of course helps reduce odors and being a good neighbor. And then finally, we're able to scale down our technology to the community level, or even a volunteer-supported level. This is a project that we're doing with a grant-funded organization. These are volunteers. They have a community-scale composting facility under the Queensboro Bridge in New York City, using small equipment and still able to achieve high level of process control and control odors. Next slide. That same small-scale system allows us to also do pilot demonstrations. So I think there's some people in this room actually will recognize this location or the sludge train at this facility. Several years ago, we ran a pilot demonstration with the Metropolitan Water Reclamation District for composting their biosolids with wood material as a pilot scale, possibly looking to convert their sludge drying basins into full-scale composting. Next slide. But besides composting food waste and green material and biosolids, we also have a municipal solid waste application we're primarily doing in Europe, which basically is taking a single stream municipal solid waste, and you can do two things with it. You can stabilize it, you can bio-dry it, and you can prepare it for energy use. Or if you can able to pull the organic fraction out of it, you can actually make a compost-like output. Next slide. So this is a facility in Hungary, in Eastern Europe. We call it an eco-complex, where they're actually taking several different processes and doing it all in one site. They do both MSW stabilization prior to energetic use, and then the clean organics, the clean green waste, the clean food waste is then separately processed into compost, all on the same facility. So in summary, I put out here, this is our global reference locations. We've been doing this for 20 years. I'm highlighting all the countries where we have our permitted facilities. So we're over 300 facilities worldwide, 30 different countries, processing over 3.5 million tons per year of organics. And really the reason of why they're using Gore Cover at all these facilities, because it's easy to operate. It does provide odor control. We do provide a high quality product. We're able to operate in varied climates. We're able to input, compost different types of input materials. We are able to control emissions. We are able to control moisture. We are able to deliver high temperatures, which is important for pathogen reduction. And we do improve water and air quality. And one of the places that we're missing a star is this great country, and I thank you for having me today. So there's my contact information, and I hope to see you all over the next 2 days. Thank you very much.